Hi everyone, in this video we're just basically going to go over uh, figuring out the domain and range when I give you the equation of a function. So what do I mean by that? So we're still doing domain and range in this video, so domain and range. So I'm just going to write continued. So say for example I give you a function like this. So I tell you f of x equals 2x plus 3, and I tell you x has to be greater than 4. Okay, so this is f of x equals 2 plus 3. This is a linear function, and x has to be greater than 4. So what we have to do is figure out the domain and range of this function with this restriction. Okay, so the first thing you should do is probably, we've always done it like through a visual approach. So let's graph this. It'll make it so much easier to do. So we have our xy axes right here. Okay, so here's the x-axis. Here's the y-axis. And we have 2x plus 3. So we know that 3 is the y-intercept, so I'm just going to draw that there. And the 2x means that it's sort of going up. So this red line represents 2x plus 3. Now here's the situation. We've been told that x can only be greater than 4. In this case, if you observe, x exists everywhere. It's positive here, it's negative here, but it doesn't fit in with the restriction that we have. So we need to restrict this graph. We need to show what this graph would look like with this restriction. So if x is greater than 4, so let's say x is 4 right here, we need to figure out what the corresponding y, so let's say x is 4 right here, we need to figure out what the corresponding y value will be over here, because x can only exist after 4. It cannot exist before 4 according to this domain restriction over here. So how do we find the respective y value? Well, we just take this 4 and we plug it in into this x over here. So y equals 2, and instead of that x, I'm going to replace it with 4, because I just want to figure out what the y value will be when x is equal to 4, plus 3. So it's equal to 8 plus 3, which is equal to 11. So this value here is 11. All right. So let's look at this a little more closely. We know that x has to be greater than 4. It's not equal to. So we know that over here, maybe I'll use a different color. We know that over here, this has to be an open circle. It has to be an open circle. And the thing is, it can only exist after 4. It cannot exist before 4. So what that means is we have to erase a significant portion. So we have to erase all of this. We have to erase all that till we get to 4. So let me just make that a little bit more neat. So, all right. So really, this graph over here goes from 4 and beyond. So I'm just going to draw a little arrow, which means that it's going to go from 4 and beyond. All right. So the question now is, what is the domain and range? So let me just scroll up a little bit. So the domain. So I'm going to write this with green. Okay, so the domain, so that's what D stands for, the domain, is we've already been given the domain. It's x is greater than 4. Remember, x domain is all the possible x values. So it's x is element of reals, right? And then we put a condition and we say x is greater than 4. Now, the range. What's the range? So the range is all the possible y values. And if we observe, it basically starts after 11 and just keeps going on up forever. So we say y is element of reals, and we say y is greater than 11. And we don't say equal to because this is an open circle. So we simply say y is greater than 11. All right? Let's do one more example of this just to clarify the concept. So basically, let's do this function. So let's say f of x is equal to negative 3x plus 1, okay? And basically, I'm going to say that x has to be greater than negative 2, okay? So once again, the first thing we have to do in order to find the domain and range is first let's plot it. So here's my xy axis. I know that, oops, let me use red. So I know that my y-intercept is 1. And it's negative 3, so it must be downward sloping. Must be downward sloping over there. I have x is greater than negative 2. So the first thing I need to do is figure out if x is going to be greater than negative 2. So here's negative 2, right? What is the corresponding y value right there? What's the corresponding y value? So if in order to do that, I just have to take this negative 2 and plug it in here. So let me do that in yellow. So y equals -3 and -2 plus 1. So negative, negative, that's positive. So 6 plus 1, so that's 7. So I know that this value right here has to be 7, okay? Next thing, it says that x is greater than -2. So in other words, everything to the right of -2 will exist. Everything to the left will not exist. So again, this is greater than, so which means that it's an open circle, right? It's not a closed circle because there's no equal to sign. And therefore, I have to erase everything that is before -2. So I'm going to erase all of that, okay? And since this keeps on going after -2, I'm just going to put an arrow over there, okay? So now let's figure out what the domain and range are. The domain, well, the domain has already been given to us. So the domain is x is element of reals, and therefore x is greater than -2. What about the range? So y is element of reals, okay? And if you observe that, well, y sort of begins not really at 7, but just below 7 and keeps going down. So in other words, the y values decrease as we're going, right? If you observe, the y values keep decreasing. So we're going to say y is less than, and when there's no equal to, because it's an open circle, y is less than 7. And that's basically the domain and range of linear functions with a domain restriction.